So let's suppose I have this sequence of shapes and I need to continue this pattern and then make some hypotheses about what's to come in the future. So first thing I'm asked is to say draw the next figure. And so I'm going to go get to that drawing tool and attempt to draw it. So it looks like I start with a hexagon and then just continue along. Oops, that one's premature. Looks like I need to rotate this one. This is the previous figure, and then I'm assuming it just continues. Seems like the most logical way to continue. So I believe that's going to be the next figure in line. So looks pretty good. So I can sketch that out or write something about it, take a screenshot. So let's go back here and just take some notes on this. This is the first term. So usually we talk about n, which figure I'm in or which term I have. And this is the first, and that's the second, and that's the third, and that's the fourth, and that's the fifth, and I just drew the sixth on the other page. As far as, let's say, the number of blocks, blocks here, this one has 1, and that one has 2, and that one has 3, and that one has 4, and that one has 5. So if I was then asked, how many figures will be in the 201st, so n equals 201. How many blocks? That's pretty easy because it seems here that the blocks is exactly the position. At the 5th position, there's 5 blocks. At the 6th position, there's 6 blocks. 3rd position, there are 3 blocks. So I could just say, hey, 201st figure are 201 blocks. Oops. All right, pretty easy. But then I have to describe it, let's say. So they say, okay, and describe that figure. Okay, that's where it gets more interesting. Well, the first figure starts with a hexagon and ends with a rhombus. The next one is hexagon, rhombus, trapezoid, then hexagon, rhombus, trapezoid, triangle, and then we start over. Hexagon, rhombus, triangle, sorry, trapezoid, triangle, hexagon. So just kind of shorthand, I could say, well, it looks like it repeats. Hexagon, rhombus, trapezoid, triangle. We just abbreviate that as tri. Over and over. Can I say where it ends? Ending with what? So that's where it gets trickier. The first one started and ended with a hexagon. The 5th one started and ended with a hexagon. What's the next one that's going to start and end with a hexagon? So I'm just going to pick on hexagons for a minute. And then if I look at that other page, the second one here ended with a rhombus, and then the 6th one ended with a rhombus. What's the next one that's going to end with a rhombus? Well, it's definitely repeating a pattern of 4. Okay, so 1, 2, 3, 4, that ends in a triangle, and then it starts back with a hexagon, 1, 2, the next one will end in a trapezoid, then a triangle, 4th one. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. So the 4th and the 8th one end with triangles. The 1st and 5th end with a hexagon. The next one that's going to end with a hexagon, well, from 1, see if we can write this down, play around a little bit. So let's play. Math is all about playing in an organized way with hexagon. At the end. I'm assuming the end is the right side here. So the first one ends in a hexagon, the fifth one ends in a hexagon, and then counting up 4 after that, the ninth one should end with a hexagon. 9, 10, 11, 12, 13, and so on. Right. Now these numbers here, the 1, 5, 9, 13, there are values of n. They're also the number of blocks in the sequence, which happens to match, but that's not always the case, depends on the pattern. What do those numbers have in common? Well, they are 4 apart, so let's just make some notes on this. They are 4 apart. Extra P there. 4 apart, but they're not multiples of 4. Multiples of 4, like 4, 8, and 12, and so on. So that means they must be multiples of 4, like plus something. So let's see, 4 plus 1 is 5, 8 plus 1 is 9, 12 plus 1, okay. So they are, it's a new color, they are multiples of 4 plus 1, comma. All right, so just a note on that, it would be inappropriate for me to write for n plus 1 to describe what I just saw here, because n refers to one of these numbers like 13. So 13 is an n, so I can't use n in 2 different places. So I can't, that would be using the variable in 2 different ways, which isn't okay. So we could either just go with this verbal cue here, or we could use a different letter for the variable, like an I or an X or something. I don't think I'm going to do that. So multiples of 4 plus 1. So, oh, right. Think about it. If you divide 4 into 5, it goes in once with 1 left over. 4 goes into 9 twice with 1 left over. 4 goes into 13 3 times with 1 left over. So that plus 1 is like a remainder. So if I look at the 201st term and I say, okay, how many times does 4 go into 201? And 4, because again, this repeats every 4 terms. 4 goes into 201. Let's see, 4 goes into 25 times, no remainder. 4 goes into 1, 0 times, remainder 1. So that 1 there, based on what I just saw, means it ends in a hexagon. Okay, what if we did like this 202nd figure? So suppose we said n was 202. And we went 4 goes into 202, 4 goes into 25 times, no remainder, 4 goes into 0 times, so remainder 2. So what would that give us? What comes after a hexagon? After a hexagon should be a, this guy here, rhombus. Okay, so this is the first, second, third, fourth, fifth, sixth figure. So if we just check that idea, if we take 4 into 6, so if n equals 6, 4 goes into 6 once, remainder 2, ends in rhombus. So this guy, the 202nd figure, should also end in a rhombus. Okay, there's a pattern within a pattern here, which gets kind of tricky to describe. But if we play around enough, we can figure out that. So now I'm pretty sure if somebody gives me any number, like someone says, just a new color here, what would the, how about 351st figure? So n equals 351. Then I'd say, okay, let's see how many times 4 goes into 351, because we have that repeating chunk of 4. And then the remainder will tell us what happens, what it ends with. So we can describe what that shape looks like. So 4 goes into 35 8 times. 8 times 4 is 32. 35 minus 32 is 3. 4 goes into 31 7 times. 4 times 7 is 28. 31 minus 28 is remainder 3. So let's see, remainder 3, what would that look like? This is a remainder 1, remainder 2, remainder 3, it should end in a trapezoid. So I could describe the 351st figure by saying, well, it goes a hexagon, followed by a rhombus, followed by a trapezoid, followed by a triangle, repeats that sequence, repeats this, and ends with the rhombus. And I would obviously write that out with more words, but that's my shorthand for what I think I just figured out here. That was fun. Thanks for playing.